Cosines, as you might imagine, is based on the cosine ratio. It's also known as the generalized Pythagorean theorem. Here's why. There's three cases, but if you look down here, doesn't the first part of it look kind of Pythagorean theorem-like? It actually is the final one, a squared plus b squared equals c squared. That one down there looks exactly like Pythagorean theorem. So it has this extra at the end. This part is for when it's not a right triangle. Okay. So watch this. If it is a right triangle, and you were doing this, it would work. The right angle would be 90. Somebody do cosine 90 in your calculator. 0. So cosine of 90 would make this 0, and it would all go away, and it would be the Pythagorean theorem. So my point is, if it was a right triangle, you wouldn't have this part. But it also works if it's not a right triangle, you just have to have more of it in here. This is for generalized any triangle. Everything else still holds. Little a, little b, little c is opposite the capital letters. The formula relates the sides with the cosine of one of the angles. So all you have to add on at the end is minus 2bc cosine a. Or b in this case, and c here. I'll show you why it works on the next page. Now this is important. This one is for an SSS and SAS. This is what law of cosines will work. Okay, flip it over. Let me show you. We're just gonna do the reasons why we get law of cosines, and then we'll try 2 quick examples. So I've labeled everything in this triangle very similar to before. This is h, the height, but I added in that this is x. If this whole length is c, this one is c subtract off x. That'll be the length of that one. That's the only new part. Okay, you'll see we're trying to show the first case on the previous page of the law of cosines. And there's 3 cases based on which side and angle you go with. Side and angle. Well done. So step 1, you have the provided triangle with how it's labeled. Step 2, apologies, but there's a little typo here on yours. It's supposed to be plus and equals, they're switched. I already switched them up here. So it's supposed to be x squared plus h squared equals b squared.
And you actually get the hypotenuse.
So same as before, right triangle there, and on the left is a right triangle. And I'm just doing Pythagorean theorem, x squared plus h squared equals b squared.
Oh.
Okay. So the reason here is going to be Pythagorean theorem. And this is Pythagorean theorem for, I'll put it in blue here, the triangle on the right, the blue triangle. The legs are h squared and c minus x squared, and then the hypotenuse is a squared. So again, Pythagorean theorem. Okay, next step. This stays the same, the h squared and the a squared, but what they're going to do is FOIL. When you do c minus x squared, it's really c minus x times c minus x, and they're just FOILing. So let's not take the time to do that, but it's FOIL, which is distributing. FOILing is really distributing, so it's distributive property. Okay, next step. Again, I like to go 2, 3, 3, 4. What changed? Well, c squared minus 2cx and the a squared stayed the same. But x squared plus h squared became b squared. Because right up here is an x squared plus h squared equal to b squared. Yeah, that was an equation too. So they just substituted them. Substitution. Okay. What we need to do is take a pause with this equation. That's good. But if you look at what we're trying to get to, it's got cosine in there. Well, we don't even have a cosine yet. So what we're going to do is take a step back and say, let's just do cosine of a. Because we have to get cosine a in there somehow. So that's what step 5 is going to be. They're just doing the cosine ratio. Starting at a, cosine is adjacent over hypotenuse. So the adjacent is going to be x over hypotenuse b. Yeah, you could put definition of cosine or just put cosine ratio. If you look at the final, we don't need an x in there. So we need to get rid of this x right here now. So they're going to solve both. They're going to solve 4x by multiplying both sides by b. Now that's similar to the law of sines one. So the result is right here. Well, those cancel on the left. You got b cosine a, and you have multiplication. Okay, and now equation number 4 and equation number 6 there. We're going to combine those. So again, we got to get rid of x. So what they're going to do is take this, because that's equal to x, and plug it in right there in that equation. And so that's how we're going to get down here to 7. The c squared minus 2, let's see, yeah, this is the same. Then for x, they're putting in b cosine a. Then the plus b squared and a squared stays the same. So just plugging in one thing, substitution. Okay, that's basically it. Now all I'm going to do is rearrange some things. So you'll notice in the next one, the only thing I do is just put the b squared first, and then the c squared, and then the minus 2b, well, there, bc, cosine a. Anybody remember this? This is probably 6th or 7th grade. We haven't done this property this year. What? It's commutative property. Yeah.
Good job, Alana.
Commutative. I didn't give myself enough. Commutative. Because I rearranged the terms on one side. Now, I'm actually thinking here, B, C. Let me think about that. No, that'd be commutative. That's fine. What?
Did you just flip it?
Yeah, for that one I did, for multiplication. Here with the adding, the addition, commutative with addition, I just rearranged b squared and c squared.
Not much.
That one we haven't done this year, but good for remembering that. That was good. Okay, and finally, now we know this one. I just switched the sides. I put a squared on the left side, everything else on the right side. Just flip sides. What property is that?
Flush?
Oh. So close. No. I just flipped the sides.
Symmetric.
Symmetric property. Good job. So there's some similarities between that one and the last one. So we got to do a little more because, yeah, just that foiling of the c minus x, plugging in for the x. And I say down here a similar idea. So that was just showing one case of the law of cosines. The other two are the exact same, but just different variables. So, okay, ready to try a couple here to finish up. Okay. Solve each triangle. Round to the nearest 10. Now here's an important note before we start. Basically, if you're doing a law of sines question, stick with law of sines the entire question. Do not jump to law of cosines. And I'd say it's probably more important the other way around. If you're doing a law of cosines here, you might do one part, law of cosines. Then you're like, oh, well now I can do law of sines. Stick with law of cosines the entire problem, because you can create accidentally an ambiguous case where it doesn't work actually for you, and it creates some error values. Okay, so stick with law of cosines the entire problem, or law of sines the entire way. Number 1, I'm actually going to just find x. We're not going to solve the whole triangle. So up here, it's already labeled, so that there just says what's labeled. For this first one, again, I'm going to go ahead and change the variables so that it's more A, B, C, what we've seen. So I'm going to call this one A, and again, it doesn't matter. I can choose any, I can choose C here if you want, it doesn't matter. Because whichever one I choose, I'm just going to go to that formula. Again, there's 3 formulas. So I'm just going to go to that one. let's see, so that's A, this is little a, this would be little b then, and this would be little c. Okay, now to decide which of the three variations of the formula to choose, it's all dependent on what the angle is. The angle is 45, and that was A. So I got to choose the first one because this is the one that has cosine A. If I called it B, it would have been this one or C. I'm going to just write down the formula for this one. Let's see, B squared plus C squared minus 2BC cosine A.
How do you know which one to use? What?
Yeah, how do you know if it's sine or cosine?
Oh,
Use cosine.
yeah, you know what? I should have started with that. I'm sorry. This setup is side, angle, side. It's a SAS setup. And law of cosines works for SAS or SSS.
Yeah, but then how do you know
Good
which
question.
Because we're starting with A.
It's all dependent on the angle you have. It's all dependent on what angle. So I have 45, and I called that one A. If I had called it a different one, I would have used what the other formula was. But so then I had to go with this one because that has cosine A. Good question. All right. So now this one, let's plug things in. Little a, I don't know. That's actually what I'm solving for. Is originally x. So it's little a. So I leave it as a squared. B squared. So that's 25 plus 11 squared. Minus 2, and then B is 25. C is 11. And then cosine of capital A, which is 45. Yeah. It's actually a lot, but check it out. If we're solving for A, all I have to do is square root. And then carefully put it in your calculator.
It's AX.
Yeah. It was originally x, so little x would be opposite. Now, I have some students who will always want to work it out first. That's fine. You can do 25 squared, 11 squared, combined, and just, that's fine if you want to do all the right side first. I'm just going to enter it all at once in my calculator, though. Square root, make sure you have 25 squared plus 11 squared, right? Or it might, sorry, it might have been 11 first.
No, it was.
Oh, okay. Minus 2, and then 11 and 25. Again, order wouldn't matter there. Cosine of 45.
I got 18.
It's 2BC.
I got 18.
It's 2BC.
I saw mine first. I like do all the squaring and stuff.
So yeah, I don't care. Yeah, if you, whichever method you prefer, working it out and then square root or just square root all of it. About 18.9.
God, that's a lot. Okay, what? Hold on. Where'd you get this? Okay.
What's that back there? Yeah, just try it out. Square root of all that, or you can go separately. Got it?
Should we go with Riley's formula?
18.9.
TBD, but probably.
Memorize that. That's a lot.
What is this for? Why are we doing it?
Is this for algebra 2?
That and this is something that not a standard. It used to be a standard for right triangles. We skipped over it. So quiz. I can just a million questions.
Well, I already had someone answer questions about my exam in Spanish.
Okay.
Okay, let me finish up example 2. We got on 1, square root of all that.
Yeah.
Okay, well, let's okay, finally, let's do, I'm just going to do one part of number 2 to finish up. I have a triangle with little a, little b, little c. So it's assuming we have capital A, B, C. Again, I just went in A, B, C, doesn't matter. Little a then will be here 4, little b will be here 3, little c 6. I mean, it could be a right triangle, we don't know. And so we can't use Pythagorean theorem or anything like that. We can do law of cosines though because it's an SSS setup. Alright, 3 seconds. Do you want me to stick with the same one up here? Start with a squared, or it doesn't matter.
Let's go with A squared.
No, you go C.
Squared.
Guys, it doesn't matter. They're all the same. So if we start, we're gonna find an angle first, and you just gotta start and pick one. Doesn't matter.
Do we have to memorize these formulas?
I'm gonna ask up here. Let's go with yes.
Yes?
Yes. So a squared. I'm just writing down the formula. Again, since we chose to find angle A, I need to include cosine of A. That's the first one. Minus 2bc cosine of A. Okay, I need to plug things in, and I need to move a little quickly. Little a is 4. 4 squared. Little b is 3. 3 squared. Little c is 6. 6 squared. Minus 2, b is 3, c is 6. And cosine, we don't have a. So notice on this one, it's not just going to be a square root. We're solving for something over here. So this one, yeah, you're going to have to do a couple steps. Now, I actually can do them in my calculator, but I'm going to show you the work. Either way is fine. So here's what most of you will probably do. You'll go ahead and square these. 16. Here, 3 squared is 9, and 6 squared is 36.
Wait,
I'm just squaring them.
but you do, in the calculator, you do the square root of everything, don't you?
Not the square.
Not for this one, that's what I was saying. Over here, when we were solving for A, yeah, but here we're solving for this. Right here, 2 times 3 times 6 is 36. So I got minus 36 cosine A. Now, be very careful. One of the most common errors here is students will do 9 plus 36 minus 36, which is not right.
36
Correct.
is part of this.
36, it's like 36x here. 36 is part of the cosine A.
So it's just 45.
So it's just 16 equals 45, and then the minus 36 cosine A. Now it's going to be, what do they call, like a two-step equation? So you're going to subtract, I got to move quickly. Subtract 45, you get negative 29. Negative 36 cosine A. You're going to divide by negative 36, so you'd have positive 29 over 36 equals cosine A. And then you can do cosine inverse. So I don't remember what the angle is. Cosine inverse 29 over 36.
Oh my gosh. 36.33.
Sounds good, thank you. And guys, then you would repeat to find B or C. Then you do 180 minus those two angles to get the other final answer.